Okay, once again, this is Richmond, and then for the first tutorial, I gave you all the basic rules that we need to know in order to calculate for the oxidation state of radicals or for some elements. This tutorial, I just want us to solve certain questions. So I wanted to learn how we calculate the oxidation state of radicals. Okay, so let's take the first radical. We have a radical. I first explained radical to be a group of atoms that stay together as charge unit when you have atoms coming together with a charge. Okay, so example of a radical, when I have CO3 2 minus, this is a radical because we have carbon and oxygen coming together with a charge of -2. Okay, so here we are asked to calculate for the oxidation number of carbon. So something like this, a calculate for the oxidation number of carbon. So let's learn and see how we can solve this particular question. Okay, if this is the first time that you are hearing of oxidation number or oxidation state, okay, don't panic, and then I know that by the end of this tutorial you'll be able to solve for all the oxidation numbers of compounds. Okay, so here one thing that you need to know, that in the 6th rule I stated that in most of the substance, oxygen having oxidation state of -2, except in peroxide. So here, this is not peroxide, so mean oxygen is having an oxidation state of -2. And one of the rules also said that the oxidation, the algebraic sum of the oxidation state of the compound, of the element in a compound or a radical, is equal to the charge carried by the radical. What I said was that if I add the oxidation state of carbon and then the oxidation state of oxygen together, I should get the charge that the radical is carrying, that's the -2. So here, to be able to solve for the oxidation state of carbon, we replace carbon by a constant, by any variable as unknown. It's like we don't know it, so we are now trying to find a carbon, that's the oxidation state. So we replace C by a variable, let's say X. So we say X here. So write the X here, which we use it to replace C because that's the unknown that we are solving for. And you know the oxidation state for oxygen to be -2, except in peroxide that is -1. So all that we need here is that we write -2. And then the -2 will be multiplied by it's multiplied by 3 here. So -2 by 3 here. Okay, and then the rule says that the algebraic sum of the oxidation state of the element in the radical should be equal to the charge carried by the radical. So now the charge carried by this radical is -2. So you equate everything to be equal to -2 like this. So all that you need to do is that we are solving for C and then replace that one with X. So -2 by 3 will give us -6. So you move on, X minus 6 is equal to -2. Okay, so what do? We just group like terms. It's like algebraic expression. So X now will be equal to -2 plus 6. Okay, so our X now equal to +4. So all that we can say that the oxidation state of carbon here in this radical carbonate is equal to 4. Okay, so let's take the next example and see how we can also solve for the oxidation state of the central atom there. So we have ClO minus like this. Okay, and we know that Cl is chlorine and O is oxygen. And then one thing that you know that always, except in peroxide and superoxide, where the oxidation state of oxygen changes, in peroxide is -1 and superoxide is -0.5. So except those substances or those compounds, always the oxidation state of oxygen is -2. So here the central atom here is chlorine. So we replace that one by any variable, by X. I prefer using X because X is a very nice variable. So Now you have X here, and then your oxygen is having a fixed oxidation number in this radical, so which is minus 2. And I said that the algebraic sum of the oxidation state of the element should be equal to the charge carried by the radical. So it's equal to minus 1, like this. So perfect. We cannot continue. Okay, so what we need to do here is that you make X the subject. So X now equal to minus 1, and then this negative 2 cross equals and become plus 2. And then you see that our X is equal to plus 1. So the oxidation state of chlorine here is plus 1. Okay, so let's move on to take another example. I know that by the end of the last example, everybody will be able to solve or find the oxidation number for every element. This one is NO. Okay, so all that we know, the rule is the same. This is the central atom N, so we replace that one by X here, and then the oxidation number of oxygen is minus 2, so minus 2 here times the subscript, which is 3, should give you the charge, that's negative 1. So you have X, and then minus 2 times 3 give it minus 6 is equal to minus 1. Okay, so we have our X here is now equal to minus 1 plus 6, and our X is equal to plus 5. So nitrogen, the oxidation state of nitrogen in this radical is plus 5. Let's take our last example, and I know that this one will help us a lot. Okay, so let's take our last example, and I know that after this everybody will be good to solve for the oxidation state of every element. All right, so you have SO4 2 minus. Somebody will say, why am I saying words like SO4 2 minus, NO3 minus without mentioning their names? Okay, another tutorial will be naming oxo atom, oxo acid, and oxo anions. So in that tutorial I'll be telling you the names of these radicals. So no problem, let's solve this one. So here the central atom here is S, so let's replace S by a variable here X. So we have a fixed oxidation number of oxygen minus 2, we multiply by the subscript, which is 4, and it should be equal to the charge carried by the radical minus 2. So here we have X here, minus 2 times 4 give us minus 8, should be equal to minus 2. Let's group like terms. X is now equal to minus 2 plus 8, and our X is now equal to plus 6. So this means that the oxidation state of sulfur, that's S here, is plus 6. Thank you for watching this video, and if you like it, subscribe and share to friends and relatives. Thank you, and let's meet in the next tutorial.